All right, how are we doing today? We are in Unit 2 talking about systems of equations, which you remember are two or more equations. In previous lessons, we solved systems of equations by graphing, which is great, but not extremely efficient. Today, we're going to solve systems of equations by substitution. And then we're going to do elimination, okay? Systems of equations have lots of different ways to solve them, and they're all equally fun. Let's jump on in. So let's use substitution to solve systems of linear equations. Here are graphs of two equations in a system. Determine if each of these systems could be represented by the graphs. Be prepared to explain how you know. Well, if I look at this first system of equations, remember a system is two equations written in with a squiggly bracket. This first system is going to be a slanted line with a y-intercept and a slope. Hold on, let's see if I can turn that off. There we go. And this second equation is going to be, if I do an xy axis, this is my x-axis, my y-axis. If I go over here to -5, x equals -5, well, that's 4. 1, 2, 3, 4, 5. This is the line x equals -5, which is not this line, so that doesn't work. This system, it's great. I have a y-intercept of 13, a slope of -7, which is a valid slope for this drawing. But the line y equals -1 does not work. If we look at our xy axis again, maybe. Okay, xy axis. Y equals -1 is a horizontal line that crosses the y-axis at -1. So that isn't correct. This next one, let's see. If I solve for y, I'm going to have -3x plus 15. That has a negative slope, which is good. A y-intercept of 15, which is good. And here I have a vertical line at x equals 8/3. Okay, I just divided both sides by 3. That very well could be this line. Okay, it could be. All right, now this next one, I have two slanted lines. This one has a positive slope, which means it's increasing from left to right. And this one is a line, y equals -8, which would be, again, a horizontal line down here at 8. So that doesn't work. So that right there is the one, and I know because I picked it apart about 2 minutes ago and it worked. Here are 4 systems of equations that you saw earlier. Solve each system. We're not going to solve graphically this time. Then check your solutions by substituting them into the original equations to see if the equations are true. So we're learning about solving systems of equations by substitution. So let's go ahead and substitute in from the sort of the easier, the more simplified equation into the harder equation. So if I substitute instead of x, I'm going to write -5 and continue on. Solve for y, you learned this in pre-algebra. I'm going to add 5 to both sides, which is the opposite of -5. I'm left with 2y equals 13. Divide by y, nope. Divide by 2. And we're left with y equals 13/2. And I'm just going to leave it like that. Okay, it can't be simplified. So it's really no big deal if I put it in a decimal form or in a reduced fraction form. It just doesn't quite matter. Sorry, I just want to make sure that I've done it the right way. Still looking. Yes, we are good. All right, let's try this next one. Again, I'm going to take the easier equation in the system and substitute it into the value. So instead of y, I'm going to write -1 equals negative 7x plus 13. Now I want to isolate the x term, so I move the 13 to the other side of the equal sign. I'm left with negative 7x equals negative 14. Divide both sides by negative 7x. And I'm left with x equals 2. I guess I'm getting so far ahead of myself. The actual solution is an ordered pair, negative 5, comma, 13 over 2. Or you can say x equals negative 5, y equals 13 over 2. Here we have the ordered pair 2 comma negative 1, or you can say y, well, we're going to start with x because it's first in the alphabet. X equals 2, y equals negative 1. Okay, it does say to check, so I could check this first equation. Let's change colors again. I'm sorry, I got so far ahead of myself. So negative 5 plus 2 times 13 over 2 equals 8. Negative 5 plus 13 equals 8. It checks out. Here I have negative 1 equals negative 7 times 2 plus 13. Negative 1 equals negative 14 plus 13, which is correct. Okay, let's try to do this one right. Okay, here I have two equations. I needed to plug the simpler one into the more difficult or complicated one, but first I want to divide both sides by 3, so x is isolated. Now I'm going to substitute it into the other equation. So instead of x, I'm writing 8/3. Okay, so here the 3's cancel. I have 8 plus y equals 15. Subtract 8 from both sides. I have y equals 7. All right, so my answers are 8/3. Let's keep with our color coding. 8/3, comma 7, or I could say x equals 8/3, y equals 7. And then I can check my work. Okay, I'm going to check my work by putting 8/3 and 7 into the equation. 3 times 8/3 plus 7 equals 15. Okay, those cancel. 8 plus 7 does in fact equal 15, so it checks out. All right, this one, there isn't really a simpler equation and a more difficult equation, but I do have one equation already solved for y. So I'm going to take that equation and substitute it into the other equation. This one is probably a tad bit more complicated. So I know y equals 2x minus 7, so let's do 4 plus, instead of y, I'm going to write 2x minus 7 equals 12. Now I don't have to do any work with the parentheses, so I can just take the parentheses down. 4 plus 2x minus 7 equals 12. Negative 3 plus 2x equals 12. I'm going to add 3 to both sides. 2x equals 15. Divide both sides by 2. X equals 15/2. Now we still need to know what y equals. That's why this one's a little bit harder, because there are more steps. So I'm going to substitute my answer for x into the first equation for x. Y equals 15 minus 7. Y equals 8. So my answers are 15/2, comma 8, or we can say y equals 8, x equals 15/2. And we need to substitute it in to make sure they work. And I am all out of room. Okay, we're going to go right down there. Y equals 2x minus 7. And 4 plus y equals 12. I am not sure I did that the easiest way. I look at this equation now, and the second system was probably a little more simpler. I could have solved that for y and plugged it into the other equation. So let's just look at that one. Let's check our work. Y equals 8. I think that's what I had. Yep. So let's plug everything into the first equation. 8 equals 2 times 15 over 2 minus 7. 8 equals 15 minus 7, which is true. We got it. All right. Now, that was a lot of mathing. All right. So let us look at these next 4 problems, and we're going to solve them without graphing, which we didn't use graphing on the last page. If we were supposed to, I was way off. It didn't tell us to use graphing, did it? Nope. It didn't tell us to graph. All right, we're getting lots of practice with substitution today, and that's all right. Okay, so this first system, sometimes the hard part is trying to figure out which to substitute into which. Well, the second equation is already x equals, so we should just take that and instead of the x in the first equation, plug in what we know x equals. So I just put parentheses where the x was, and I substituted y plus 4 because that's what x is. Now I distribute the 5, and I get 5y plus 20 minus 2y equals 26. So now I have one equation, one unknown. Let's collect like terms and solve for it. So I have a positive 5y and a negative 2y. Collect those, I get 3y. And then I'm going to subtract 20 from both sides. That gives me 6. Divide both sides by 3, and I have y equals 2. Plug that back into either equation. It doesn't matter. I'm going to plug it into the second one. 2 plus 4 equals x. So x equals 6. And it is always a good idea to check your work. It just takes an extra minute, and you know you get the right answer. So let's plug it in. I'm going to do 5 times 6 minus 2 times 2 equals 26. So 30 minus 4 does in fact equal 26. I feel pretty confident. Cool? All right, let's try this next one. So our second equation is already isolated for p. Let's go ahead and substitute that into the first equation for p. So what I always do is literally where the p was, I put in parentheses and substitute what I know. Then I distribute. So 2m minus 4m, because I just did that distribution, minus 20 equals negative 6. So collect like terms, negative 2m, and then add this side. Negative 2m equals 14. M equals negative 7. Okay, we're almost done. Let's go ahead and figure out what p is. I'm going to grab the second equation again because it's already isolated for p and substitute what we just solved m to be. So p equals negative 14 plus 10. P equals negative 4. I can't write that in an ordered pair because it's not x, y. So I can just say m equals 7, p equals negative 4. Now let's go ahead and substitute to see. We're going to check our work. So 2 times m minus 2 times p equals negative 6. So negative 14 plus 8 equals -6. Negative 14 plus 8 is in fact -6. So that is a true statement. 2 more. I'm showing all my work too in hopes that it helps. Because there's a lot of work to be shown in substitution. Okay, even when we do elimination, it'll be a lot of work, and you guys will pick your favorite method, and it'll be great. All right, so without graphing, I've got a simpler equation and a more complicated equation. We always want to mess with the simpler equation and plug that into the more complicated equation. So I'm going to divide both sides by 2, and I get D equals 4F. And now we're going to substitute that. 18 minus 4F equals 2, and instead of D, we're substituting D equals 4F. Go ahead and do your multiplication here. 2 times 4 is 8. Now I'm going to add 4F to both sides. 12F equals 18. F equals 18 over 12, which does simplify to 3 halves. And then we're going to plug that back in. 2D, that's a B. 2D equals 8 times 3 halves. So 2D equals 12. Divide both sides by 2. D equals 6. So I know that F equals 3 halves. D equals 6. Let's go ahead and check. We're going to plug it into that second equation. 18 minus 4 times F, which is 3 halves, equals 2 times D. So 18 minus 4 times 3 halves, 6. So 18 minus 6 does in fact equal 12. We got it. Cool? All right. I really do not want to substitute in with a fraction. But what I've told you is take this simpler equation and substitute it into the harder one. So let's go ahead and try it. So W plus 1/7, and instead of Z, that's 1/7, sorry. I'm going to write 3W minus 2 equals 4. So go ahead and distribute that 1/7. W plus 3/7, W minus 2/7 equals 4. If I add these two together, I get 10/7 W, and you can check that with your calculator. And I'm going to add 2/7 to both sides. So 10W equals 4 plus 2/7. 30 over 7. All right, I'm going to divide both sides by 10/7. And that gives me W equals 3. It's kind of amazing how that messiness cleans up right there at the end. Just checking my work. Yep, 3. Okay, let's figure out what Z equals. So I can say Z equals 3W minus 2. 9 minus 2 is 7. And if I want to check my work, I can plug what I know into this equation. 3 plus 1/7 times 7 equals 4. 3 plus 1 does in fact equal 4. We got it. All right, so what strategy would you use to solve each system? Explain your reasoning. You can use these sentence starters to formulate your answer. So I would choose to solve system blank by substitution because, so if I look at system 1, I would not use substitution because I don't have anything solved for a variable. With the system 1, we're going to learn elimination in the next lesson. Elimination. And this one is perfect for elimination. And we'll explain why at a different time. Okay, system 2, I have one equation solved for y, so I can substitute that right in there. So I would definitely use substitution because I already have one equation with a variable isolated. In system 3, I would not use substitution. I would use elimination. And we will explain why later. Just giving you a clue. That's our whys. It'll make better sense when we learn about elimination. Okay, so lesson 13. I can solve systems of equations by substituting a variable or an expression. I know more than one way to perform substitution and can decide which way or what to substitute based on the given equations, on how the given equations are written. And we have one new vocabulary term, system of equations, 2 or more equations that represent the constraints in the same situation form a system of equations, and they're always written with the squiggly bracket. We've got an equation and an equation. Okay, good work today.